Hello and welcome. In this video, I want to share my experience with you transitioning from using Perl to learning Golang. I hope you'll find this useful if you're getting started with Go as well. In this video, I want to cover a bunch of things, starting with installing Go and writing a classic Hello World program. Then I will talk about modules and the type system, followed by comparing the different data structures in the two languages. Last, I will cover debugging tools, function calls, and share a few common pitfalls. Go is available for all relevant platforms. If you're running Red Hat, CentOS, or Fedora, you simply install it using the package manager yum. If, like me, you're on Mac and you have Homebrew installed, you can get Golang from there. In all other cases, you can go to golang.org and download the distribution packages for your operating system from there. This is also the first tip when you're Googling for information on Go and can't seem to find what you're looking for. Type Golang instead of just Go. Go is such a common word that it will yield some bad results, but searching for Golang should always get you there. Let's start by looking at a very simple Hello World program. Since Golang, unlike Perl, is compiled, we don't need a reference to the interpreter binary in the first line. Instead, we give our package a name, which is usually just main. After this, we load all the modules that we need. This is equivalent to the use command in Perl. Lastly, we define our main function. In Perl, you would not have to do this, but Golang, like C, requires that you have a function called main as the start point of your program. Effectively, this program only runs one command, println from the FMT module. Println includes a trailing new line, while print does not. The FMT module also includes other useful functions such as printf, sprintf, and so forth. Golang has an extensive module system and almost everything is contained in modules. You'll find yourself loading the same modules quite often, like FMT, IO, strings, and others. If you're looking for a specific module, check out awesomego.com, which has a curated list of modules sorted by category. As you will see, Golang is generally stricter than Perl, and imports are the first place where you will encounter this. Of course, your code will not compile if you reference a module that is not loaded, but it will also not compile if you load a module and then not use it. This has two advantages. You'll save memory by not loading unnecessary modules, and the resulting binary will be smaller as it does not contain bloat. To make module management a bit easier, you can use the go imports command to have your import statements automatically updated. If you use an IDE to write your code, you can integrate this so that it is automatically run when saving. You can install new modules using go get. This will get you the latest version of that module. The module URL does not need a protocol such as HTTP or HTTPS. When it comes to data types, Perl plays fast and loose. You can see in these two examples that Perl tries to guess what the programmer meant. While this works well most of the time, it's an accident waiting to happen. Golang, on the other hand, is very strict. Running the same command will get you a compile time error complaining about mismatched types. A is a string, while 1 is an integer, and Golang has no way to bring these two together. So you, as the programmer, have to make a decision whether you transform A into an integer, which is going to be difficult, or if you transform 1 into a string, which is probably what you want. You could do this by using the I to A function from the string conversion module. Golang has a set of built-in types. Strings and booleans are very straightforward. There is also a whole class of integers available. If you do not define the size of an integer, it will depend on your system being either 32 or 64-bit. You can create integers and unsigned integers of different sizes, but be aware that you will not be able to add them easily as they are considered different types and will have to go through a conversion first. Lastly, you have float for floating point numbers and also the complex type for complex numbers. But I have to say that so far I have not used this type. When I first read about creating your own types in Golang, I could not see a good use for it, but it is actually quite handy. In this example, I have created the types euro and dollar, which are both float 32 under the hood. Having these defined prevents me from accidentally adding euros and dollars together, which would be possible if they were just floats, and ensures that they have to go through the proper conversion first. The same applies to measures such as Celsius and Fahrenheit, centimeters and inches, fluid ounces and millimeters, and so on. To create a variable in Go, you can use two ways. The first one is the verbose way, which I prefer. You use the keyword var followed by the name of the new variable, followed by its type. You can define a value at initialization, but that is optional. If you do not, the type will be initialized with its default value. For a string, this would be just an empty string. For integers, this would be 0. The shorthand version is quicker to write, and Go will automatically assign a matching type to the value that you specified. I prefer the verbose version, as this forces me to think about each variable and its type, and also makes the code easier to read. Now that we've covered the basic types, let's look at the more complex data structures. In Perl, there are one-dimensional and multi-dimensional data types. Arrays and hashes are one-dimensional, while arrays of arrays, hashes of hashes, etc. are multi-dimensional. Go has an array structure similar to Perl, but with one important difference. Arrays in Go have a fixed length. I don't know about you, but I've always used arrays of variable length in Perl, adding and removing elements during runtime. In the code example, we create an array of strings with a fixed length of 2. Then we set the first element to be hello and the second element to be world before we print it. If we try to add a third element, we would trigger a panic. The type that feels more like a Perl array is called a slice. A slice is basically just a different representation of an array, which gives you the ability to add and remove elements. Just like with arrays, the first element is stored at position 0. In the example code, we create an empty slice and add 2 elements to it before printing the whole slice. Go will auto-format the slice to be in square brackets and use space as the delimiter. Let's see how we can go from a simple array to a multidimensional one. In this example, we create a 2-dimensional array of integers. We need to use the make command to initialize it before use. If we do not do that, we would run into a null pointer exception. The same is true for hashes, which we'll see in the next slide. In Golang, hashes are called maps. As Go is strictly typed, you need to define the data types for the keys and the values in the map. Like slices, maps need to be initialized with a make command before they can be used. If you try to add an element to a map that's not properly initialized, you will run into an exception. Except for its strict typing and the need for initialization, maps and hashes are very similar in the two languages. Creating a map of maps or a hash of hashes is straightforward, although the readability of the command itself is not that great. You basically create a first map and then define the values of that first map to be another map. In the example here, the first map uses strings as keys. The second map also uses strings as keys and stores integers as values. It's important to remember that not only do you have to initialize the first map using make, you also have to do the same for all the maps inside the first map. On the plus side, accessing maps of maps is very similar to Perl. You simply concatenate the different keys and get or set its value. A struct is a data type that is supported in Perl by the class struct module, but is less common than it is in Go. A struct is basically a meta type, binding one or more types together. In the example, we define a struct named student. This struct consists of two strings storing the first and last name and an integer storing the student's age. You can use structs instead of hashes, which may make your code more readable and has the advantage that you will be alerted when data does not match the struct rather than putting it into a map that has no such checks. You can also create arrays of structs and map of structs. All of this is possible. When you're starting with a new programming language, understanding the data structures can be difficult, and you may have to add a lot of debugging code at the beginning to better understand what is going on. In Perl, I was always using data dumper to check data structures and generate debugging output, so I searched for something similar in Go. My preferred module for this is spoo, which is hosted on GitHub and can easily be installed using go get. The dump command from the spoo package will generate an output that is similar to Perl's data dumper, but contains some additional information such as string length, array size, and more. In Perl, functions are very flexible. You can pass them any number of arguments and it may return a different number of results. In Golang, functions need to be defined properly and always be called with the same number of arguments. It will also always return a specific number of results of a specific type. This allows Go to check your code. You will get errors if you're not providing the right number of arguments to function call, and you will also get an error when you do not catch all the values that are returned. In the example, we have two functions. The dummy function takes two parameters, a string and a boolean, but does not return any result. You could use the variables foo and bar inside that function. Unlike Perl, these variables are local to the function and you cannot change a global variable from within a function. The second example requires only one parameter, an integer. It also returns an integer. Inside the function, we just do a very simple multiplication. Let's now look at some common pitfalls. Golang uses the C commenting style, which is different from Perl. Single-line comments start with 2 slashes instead of a hash. Multi-line comments are a bit more convenient. You start them with /* and end them with */. With this style, it's much easier to comment out big blocks of code. Another important pitfall in Go is scope. In Perl, variables are global by default. In Go, they are not. In the previous slide, we saw how variables are handled in functions. Here we see the variable x being defined inside an if statement using the shorthand form. Afterwards, we try to print the variable, which fails. In Perl, this would work, but with Go, a variable only lives inside its scope, in this case inside the if clause. If you're using indentation, it becomes easier to track the scope of a variable. It only exists in its indentation level and below. So when you define a variable, consider its scope first and make sure you define it at the appropriate level in your code. One thing to note about math operators in Golang is that there is no built-in to calculate the power of. In Perl, you can do this with 2 asterisks, but Golang does not support that. If you need this, look at the pow function from the math module. Another thing that may be confusing is the use of backticks in Golang. In Perl, backticks are used to execute system commands. In Golang, however, they mark raw strings, which would use single quotes in Perl. One very important point to look out for are array and slice boundaries. In Perl, accessing any undefined element in an array will simply return undef. However, in Golang, you will run straight into a runtime error, bringing your whole program to a halt. So make sure you check those boundaries. Last but not least, here is a common error when calling functions. In Perl, you can just call a function by its name and not provide any parameters, that's fine. In Golang, on the other hand, the function's name returns its memory address. Even if your function does not require any parameters, you will still have to call it with empty parentheses. Alright, this is everything I wanted to share with you today. I hope you found this useful. If you did, please leave a like. If you know any other pitfalls, please post them in the comments down below. Thank you for watching and have a good day.